Have you ever heard thunder so loud that it felt like the sky itself was tearing apart? A blinding flash of lightning, and then, seconds later, a deafening roar that rattles your chest. But why does lightning, a simple spark of electricity in the sky, create such an enormous sound? Today, we'll journey into the heart of a thunderstorm to uncover the science, the beauty, and the danger behind thunder, nature's most electrifying voice. To understand thunder, we must first understand lightning. High above us, within towering thunderclouds known as cumulonimbus, nature begins to charge itself like a giant battery. Inside these clouds, strong updrafts lift tiny ice crystals to the top, while heavier hailstones fall downward. As they collide millions of times per second, electrons are stripped away and accumulate in different parts of the cloud. This process separates electric charges. Negative charges, or electrons, gather at the bottom of the cloud. Positive charges, or protons, rise toward the top and even build up on the ground below. When the electric field becomes too strong, around 100 million volts per meter, or 10 to the 8th V/m, the air can no longer act as an insulator. A violent discharge is unleashed. Lightning has been born. The average lightning bolt is about 5 kilometers, 3 miles long. It carries around 30,000 amperes of current and reaches temperatures of 30,000 Kelvin. That's about 5 times hotter than the surface of the sun. Imagine a narrow channel of air, no wider than your finger, suddenly heated to tens of thousands of degrees in a fraction of a second. What happens to the air inside that channel? It explodes outward. Air expands faster than the speed of sound, forming a shock wave that races through the atmosphere. This shock wave is what we call thunder. Let's look closer. Sound is simply a vibration, a wave moving through air. When lightning strikes, the rapid heating causes the surrounding air to expand explosively and then contract just as quickly. This creates alternating zones of high pressure and low pressure, forming a sonic ripple that spreads outward in all directions. The initial crack you hear, that sharp crack, comes from the section of lightning closest to you. The deep rumbling that follows is the same sound, but stretched and delayed because it's traveling from other parts of the lightning channel, often several kilometers away. Since sound moves through air at about 343 meters per second, or 1,125 feet per second, and lightning's flash is almost instantaneous, we can use thunder to estimate distance. Count the seconds between lightning and thunder, then divide by 3. That's how many kilometers away the lightning struck. So, if you see lightning and hear thunder 6 seconds later, it means the strike was roughly 2 kilometers, or 1.2 miles away. Thunder isn't just one boom, it's a symphony. Each bolt of lightning is jagged with multiple branches and twists. Each segment produces its own sound wave, echoing off clouds, mountains, and buildings. By the time these waves reach your ears, they've combined into a mix of cracks, rumbles, and echoes, like an orchestra of chaos. Close lightning produces a sharp, ear-splitting crack, sometimes accompanied by a shock wave that you can feel physically. Distant lightning produces a low, rolling rumble that can last up to 20 or even 30 seconds. In rare cases, you might even hear thunder rolls, echoing multiple times, especially in mountain regions or near valleys, where sound waves bounce and overlap. Now, here's where it gets fascinating. When the air in the lightning channel is superheated to 30,000 K, its pressure skyrockets to over 10 atmospheres. That's 10 times the pressure at sea level. In less than 1,000th of a second, the channel expands violently and then collapses as the air cools. This rapid compression and decompression create shock waves, similar to the ones produced by explosions or supersonic jets. In fact, a nearby lightning strike can reach 200 decibels, briefly making it louder than a rocket launch. That's why thunder can shatter windows, trigger car alarms, and even vibrate the ground. Fun facts about thunder and lightning. A single bolt of lightning can contain enough energy to power a 100-watt light bulb for 3 months. There are about 1.4 billion lightning flashes on Earth every year, roughly 44 strikes per second. The longest recorded lightning bolt occurred over Brazil in 2020. It stretched an astonishing 768 kilometers, 477 miles across the sky. Lightning can strike the same place twice. In fact, the Empire State Building is hit about 25 times every year. The sound of thunder can travel up to 25 kilometers, 15 miles, depending on air temperature, humidity, and wind. And yet, despite its power, thunder itself is harmless. It's the lightning you must fear. Thunder is simply the sound of air trying to recover from being torn apart by nature's electricity. For centuries, humans have been both terrified and fascinated by thunder. Ancient Greeks believed it was the sound of Zeus hurling his mighty bolts. The Vikings thought it was Thor's hammer striking the heavens. Even in modern times, thunder retains its mythic power, reminding us that nature, for all our technology, still holds dominion over the skies. So, next time you see lightning flash across the dark sky, pause for a moment before you count the seconds. Remember, in that instant, the air became hotter than the sun. Atoms were ripped apart. Sound raced faster than you could think, and thunder was born. A sound that reminds us the universe speaks, not in words, but in thunder. If you enjoyed this journey into the science behind the storm, make sure to subscribe for more deep dives into the mysteries of nature and the universe. Until next time, keep looking up and stay curious.